everybody. Today we're going to learn about a couple of concepts in biology that are important to living things, not only on an organism level, but also at a cellular level. We are going to talk about how cells maintain homeostasis by controlling what goes in and out of the cell. A few terms we need to go over. First of all, this is water. It is the universal solvent, and anything that dissolves in it is a solute. So I'm going to put food coloring in this water and make a solution. Okay, so you can see it's concentrated in the center, but it is spreading out towards the edges of the glass. This is referred to as following the concentration gradient. As the food coloring moves from an area of high concentration in the center to an area of low concentration outside, it is following the concentration gradient, going from high to low concentration. It doesn't take energy. I'm just going to leave it sitting here, and over time, without stirring it, without adding heat, it will eventually spread out or disperse evenly. The second idea that we're going to look at is when we have different types of solutions. In this cup, I made a salt solution, very, very salty. I poured a lot, I'll pour some more in it, that is called hypertonic because compared to the cells that make up the celery, it's very, very salty. So I'm going to put those in there. This solution is just plain water. It is referred to as hypotonic because it has low salt or solute compared to the celery. Pure water has less salt than the celery. So I'm going to put these in the pure water or hypotonic solution. And over time, we'll see what the effect is on these cells and their tissues based on being in either a high salt, hypertonic or high salt solution, or a hypotonic low salt solution. There's a third type of solution that is referred to as isotonic, which means that the solution is the same as the cell itself, and it would be in equilibrium or homeostatic balance. Iso means same, kind of like this triangle. In geometry, you learned that an isosceles triangle has two equal sides. So we'll check out these different solutions, and you can already see how the food coloring's really beginning to spread out evenly. And we'll see the impact of this passive transport given different solutions over time tomorrow. Alrighty, we're back to look at our results. You can see that the food coloring is completely evenly distributed throughout the water. It did follow the concentration gradient. The food coloring moved from a high concentration to a low concentration until it became evenly distributed throughout the entire glass of water. So this is diffusion. Let's take a look at our different solutions. Remember we had hypertonic, which is high salt, and hypotonic, which was actually pure water, which had obvious less salt. Let's look at pure water. So we take out our celery sticks, and they're pretty rigid, and in fact they're crisp. So water went into the celery sticks and caused those cells to swell up and have what we call turgor pressure. They're nice and stiff, okay? Which is why when you water plants, they don't wilt, because they've absorbed water. Let's take a look at the hypertonic solution, which is high salt. Okay, so you can see it's definitely not rigid. Obviously, the water has left these cells. It has gone from an area where there was more water, which was the plant tissue, the plant cells, into an area where there was more salt. And I mean, there's so much salt, I can actually still just pick it up. It's so super concentrated that no more salt will dissolve. And so we see that adding a hypertonic solution to a plant, in this case the celery, can have negative effects on the plant and cause it to wilt and actually kill it. So that is our results. Again, you have a hypertonic, high salt solution that caused the cells to shrivel, and then the tissue became loose and limp. And we have a hypotonic solution that absorbs the water and becomes kind of crispy, and the cells become tight with what we call turgor pressure. And don't forget, isotonic is when the solution is the same as the cells in terms of concentration of solutes. Have a great day.